Why is it easier to remember that a person's job is a baker than it is to remember that their name is Baker? This is the Baker-Baker paradox, and it is a key piece of evidence that memory is not a logical computer. It appears to be a kludge, a clumsy, context-dependent system, whose strange quirks reveal its evolutionary origins. The nature of recall shows this. A computer's memory is content addressable. It finds a file by a specific name. Memory, in contrast, is contextual. Information is stored in a vast web of associations. The job baker creates rich connections, such as the smell of bread or the image of a white hat. The name Baker is an arbitrary fact with few connections. This reliance on connections, or cues, is a direct evolutionary inheritance. An ancestral organism did not need to recall abstract data. It needed to have its memory triggered by the environment. The sight of a certain footprint needed to cue the memory of a predator. The smell of a specific plant needed to cue the memory of poison. The memory system is a kludge because it still operates on this ancient cue-based software, making it effective at remembering things triggered by context, but ineffective at recalling isolated facts on demand. The unreliability of memory can also be seen as a feature of this Kluge design. Memories are not replayed like a video. They're reconstructed from fragments. While this leads to inaccuracies, such as in eyewitness testimony, this flexibility was a survival advantage. An ancestor did not need a rigid replay of one lion attack. It needed a flexible gist of the memory, the general size and speed of the threat, that could be adapted and applied to a new encounter with a different predator. Rigid recall is brittle. Reconstruction is adaptive. The physical layout of memory also reveals its haphazard construction. There is no single memory center because new systems were not built from scratch. They were repurposed. Procedural memory, how to do things, was layered onto the cerebellum, an ancient center for motor control. Episodic memory, what happened was layered onto the hippocampus, a region originally used for spatial navigation. Memory is a kludge because it is a messy patchwork of old systems forced to do new jobs. This patchwork design is prone to binding errors because the different features of a memory, like color, shape, and location, are stored in separate parts of the brain. They are actively bound together during recall. When this process fails, it can create an illusory conjunction. An individual might see a red square and a blue circle, but later recall seeing a red circle, incorrectly binding the color from one object to the shape of another. It is a direct symptom of a memory system that stores information in fragments. This memory system is a kludge because it prioritizes long-term retention over fast acquisition. This is demonstrated by the spacing effect. Information is retained better when it is studied in sessions spaced out over time, rather than crammed all at once. A computer's memory does not care about spacing. It records data instantly. The brain's Kluge system requires time for connections to solidify, a design that is inefficient for cramming, but effective for the gradual long-term learning that was essential for survival. The structure of memory then appears not to be based on random errors. They seem to be the predictable outcomes of a system designed not for accuracy, but for survival. It is a system built for a dangerous past, operating in a data-rich present, with its quirks serving as a constant reminder of the long evolutionary journey that shaped it.